Dear students, today we are discussing Fourier cosine and sine transforms. Okay, I think you have studied the Fourier integral and Fourier cosine series, sine series in the previous classes. So here we are discussing Fourier cosine and sine transforms. Okay, so what is the definition of Fourier cosine transform? So in the previous section, Fourier cosine integral, that is equation number 10 in 10.7, that is given in the last section. Yeah, this one, f of x into a or a of w, integral a of w cos wx dx, where a of w is equal to 2 by pi into integral 0 to infinity f of v cos wv dv. Okay, you can use that formula here. We have f of x equal to integral 0 to infinity a of w cos wx dw. Okay, let's we set here w is equal to root of 2 by pi into f c cap of w. Okay, c refers for cosine. Okay, so what will be if we write aw like this, what will be f c cap of w? Here we have 2 by pi, so we have to select root of 2 by pi, so remaining time will be root of 2 by pi. So root of 2 by pi into integral 0 to infinity f of x cos wx dx. Okay, so how can we write f of x? So f of x equal to root of 2 by pi integral 0 to infinity f c cap of w. So instead of this term, we can write it as f c cap of w cos wx. We have to substitute the expression for aw from here to here, and then we have to use the alternative notation for this term like as f c cap of w, and using this f of x integral 0 to aw cos wx, we can easily write it as f of x is equal to root of 2 by pi integral എൻ്റെ വണ്ടി എവിടെ കൊണ്ടിടാനാണ്? ഞാൻ ഡ്രൈവറല്ലേ. വേറെ വണ്ടി അല്ലെങ്കിൽ ബൈക്ക് ഉണ്ടായാലും മതി. ബൈക്ക് ആരുള്ള? എൻ്റെ ഒരു ബൈക്കില്ല. അല്ല, ഇതുണ്ടാവും, ഹെൽമെറ്റ് ഉണ്ടാവും. അത് മതി, എനിക്കിരിക്കാനാ. ഓക്കെ മതി. ശരി ഓക്കെ ഞാൻ വരാം, അവിടേക്ക് വരാം. ഓക്കെ. So f of x equal to integral root of 2 by pi integral 0 to infinity f c cap of w cos wx dx. So this is usually called Fourier cosine transform of f of x. F c cap of w is called Fourier cosine transform. Okay. So what will be f of x? F of x is called as inverse Fourier cosine transform. Inverse Fourier cosine transform. Okay, of f c cap of x, f c cap of w. So what about Fourier sine transform? Let us similarly we can write f of x equal to, we can consider this, what is this f of x equal to integral 0 to infinity b of w sin w of x, b of w is equal to 2 by pi to integral 0 to infinity f of v sin wv dv. So without root 2 pi, that means the remaining term root 2 by pi integral 0 to infinity f of v sin wv dv, that Fourier sine transform. Okay, so instead of 2 by pi, we use root of 2 by pi integral 0 to infinity f of x sin wx dx. So f cap s of w, and the corresponding inverse sine transform will be, as in the previous Fourier cosine transform, we can rewrite it as f of x equal to a root of 2 by pi integral 0 to infinity f of fs of w sin wx dx. S refers for sin. Okay, so this is the transform. So you can look at this example, that is Fourier cosine sine transform. Find the Fourier cosine and Fourier sine transform of the function f of x in k is 0 less than x less than a, and 0 if x greater than a. So what is f cap of fc cap of w, that equal to root by root of 2 by pi into, we can use the formula integral 0 to infinity. So instead of integral 0 to infinity, we use only integral 0 to a, because the f of x will be non-zero only in that region 0 to a, so we will use only that. So integral 0 to a f of x, that is k into cos wx dx. So after integration it will become like this. Integration and substituting a and 0, you will get root 2 by pi k into sin a w by w. Okay. Similarly, what is sine transform for the same function? Root of 2 by pi k into integral 0 to a sin wx dx, that equal to root of 2 by pi k into 1 minus cos a w by w. Okay. So that is the Fourier sine transform. So this is another example, Fourier cosine and sine transform of exponential function. Okay, you can do this problem also. Another is linear. This is the property of transforms of derivatives. Okay, this is some we are discussing in this section, some properties of cosine and sine transforms of derivatives. Okay, so we consider f of x is absolutely integrable on positive axis and piecewise continuous. We have Fourier cosine and sine transform. So af plus bg as also Fourier cosine and sine transform, and moreover so that is linearity property of cosine and sine transform of a function. Okay, so what is Fourier cosine series? fc of af plus bg that is equal to root of 2 by pi integral 0 to infinity. What is the function? We have used af of x plus bg of x cos d of x, then into cos wx ds. You can multiply each term and take the constant outside. You will get a into root 2 by pi integral 0 to infinity f of x cos wx dx plus b into root of 0 to infinity g of x cos wx dx and the right hand side is we can rewrite it as fc of f and b plus b into fc of g. So this is the formula we have obtained. I think you could understand the linearity property, and moreover similar approach can be adopted for instead of sine we can use, instead of cos we can use sine, and you will get Fourier sine series, linearity property for Fourier sine series. Now we consider cosine and sine transform of derivatives. So what will be that? That's a good research problem. What will be the cosine and sine transform of derivatives? What will be the cosine and transform of integrals? So these are some answer or theorems that giving answer to that type of questions. Okay. Let f of x be a continuous and absolutely integrable on the x-axis. Let f dash of x be piecewise continuous on every finite interval. and let f of x tends to 0 as x tends to infinity. Then fc of f dash of x equal to w into fs of f of x minus root 2 by pi f of 0. So there is a relationship between Fourier cosine series and Fourier sine series that can be drawn from this formula. Okay. Moreover, fs of f dash of x equal to minus w into fc of f of x. That is another formula. Okay. So some type of relationship we can feel in this theorem. So this let us consider the integration by parts. fc of f dash of x equal to root 2 by pi integral 0 to infinity f dash of x cos wx dx. So after integration, first let us consider this as a first function. So this cos wx as a first function. So first function to integral of second plus minus integral 0 to infinity derivative of first function into integral of second in that regions. Okay, that is, you know, the integration step. I think you know all the properties of integration. You can apply that property. So you will get minus 2 root of 2 by pi f of 0 plus w f of s. The second time is nothing but what is that? W into, this is actually sine transform, Fourier sine transform. Okay, so we can write like this. If we substitute infinity, you can see that we are considering f of infinity is 0. Okay, we are considering the extreme existence. We are assuming the existence, so we are assuming the existence. Yeah, f of x tends to 0 as x tends to infinity, so f of infinity will be 0. So we have only f of 0 here. Okay. Next, fs of sine Fourier sine transform of the derivative. You can try for the second derivative, third derivative, etc. Okay, this is a open research problem, or computation of Fourier sine cos transform of the what is that? Nth derivatives is a research problem. I could not see anywhere the result of that problem. Neither is a result problem. fs of f dash of x equal to root of 2 by pi into integral 0 to infinity f dash of x sin wx dx. So after integration, we can see that take the first function as sin ws, and you can use the integration technique. Then you can see that what is that? This is actually 0. When we put 0, sin 0, 0, f of infinity 0. So this is only minus wfc of wx. So we obtain two relationship between Fourier cosine transform and the sine transform. Or this is a problem we have mentioned. It is that the Fourier sine transform of the second derivative. We can iteratively compute this Fourier cosine transform and the Fourier sine transform for the second derivative, because instead of first derivative we consider second derivative. So instead of function we consider first derivative and put that relation, put the formula in the equation for a and b, and you will get the result 5a and 5b. Okay. Yeah, this is a problem for find the Fourier cosine transform of fc of e raised to minus x of f of x equal to e raised to minus x, where a greater than 0. Look at these steps. What is the step? What is the second derivative of e raised to minus x? That is a square into e raised to minus x. Okay. So you can replace ഒന്ന് നമ്മുടെ രജിസ്റ്ററിൽ നോക്കൂ. ഒന്നൊന്നും എനിക്ക് കമ്പ്യൂട്ടർ എന്തോ വന്നിട്ടുണ്ടോ, എന്തോ ഒരു പി ഡി ഫണ്ടിൻ്റെ അല്ല, കഴിഞ്ഞ ഇത് ഏത് വർഷം വരുന്ന ഈ ജൂൺ തൊട്ടൊന്നും വന്നില്ല. പക്ഷെ കഴിഞ്ഞ ജൂണിന് ശേഷം ഈ ജൂൺ തൊട്ടൊന്നും വന്നിട്ടില്ല. ഈ ജൂൺ തൊട്ട് ഓക്കെ, ശരി, ഓക്കെ ഓക്കെ ഓക്കെ. ഈ ജൂൺ തൊട്ടോ ഒന്നും വരാം. ഓക്കെ ഓക്കെ ഓക്കെ, ശരി. So this is S and FC of F. Yeah, FC of X. That equal to FC of F double dash. So instead of this one, we can write the using the linearity property. Okay, when we using the linearity property, when we apply the Laplace cosine transform equation, and using the linear property, we can write like this. So that is right side is exactly equal to from the equations, that is minus w square fc of x. You can iteratively use this equation. Yeah, this equation minus w square fc of f of x. Okay, so when we use that equation, we can see that what is f dash of 0. F dash of 0 is nothing but that will be f dash will be minus. Okay, that will be minus a. So it will become plus a into root of 2 by pi. You can see that this is you can take the similar terms, a square plus w square fc of x equal to a into root of 2 by pi. Now you can see that this Fourier cosine transform of e raised to minus ax will be, what is that, root of 2 by pi here, a here, and we can take this a square plus w square to the right side and it will become the denominator. Okay, yeah. So a by a square plus w square. Okay, a greater than 0. Hello. എപ്പോഴാ ഓക്കെ, ശരി 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 ശരി. സുഖമില്ലെങ്കിൽ പിന്നെ അത് ചെയ്യുന്നതാണെങ്കിൽ ഓക്കെ, ഓക്കെ, ശരി ശരി ശരി. Tables of Fourier cosine and yeah, that is given in the table 11.10. Where is the table? Oh yeah, let us check the table later. So I think this is clear for you. Next we consider we don't want to consider if it is available in the syllabus, we can discuss. Let me look at the syllabus at first, then only we have to discuss this theorem. So that will be discussed in the okay. This is not required. And finally you can understand the convolution concept of it. Anyway, all these things will be discussed in the next class, no problem. This is the table we have mentioned in the last exam. Okay, you can try for getting this, getting the answer of these problems. Okay, you can at least try for these problems, or you can use this table as such. Anyway, no problem. Uh, this is a table 2 Fourier sine transform. You can note these transform equations. Sometimes it may ask in the examination, so you have to try for getting these transforms. Okay, so we will discuss that section in the next class. Okay, here they have given the summary, and you refer this summary also. This summary will guide you to remember the basic concept we have discussed. I think we have discussed all these things, all these concepts in the last 2 or 3 classes. You have to refer this summary also. Okay, you just go through the syllabus and at least study the contents in the syllabus of our topic. Okay. And moreover, you can write these equations as that given in these tables in your notebook, and so that you can remember at least expressions. Okay. Okay.